Kia ora Year 12. This video is the first one that I'm going to make about the discriminant in a quadratic equation. So the discriminant is a number that we can calculate for any quadratic that's very, very useful. It tells us how many real roots has a quadratic got. So let's just draw the three cases that we've got, and then we're going to go through this in a lot more detail. And at the end, this goes with the Walker book, pages 60 to 62. So when we've got a quadratic, we can draw it in a few different ways. I'm going to work with a quadratic that's one that's an x squared one. In other words, it's one that is looking like this, up the right way. Everything that I'm going to say works just as well if I'm dealing with an upside down quadratic. Okay, so that's one where I've got a negative first coefficient, like negative x squared blah blah blah, or negative 3x squared. But I'm trying to keep this reasonably simple, so we're going to forget the upside down ones for now. Okay, so there are three situations that we could have when we've got a quadratic. And what we're interested in is how many times does our parabola cross the x-axis. So the first one is the one that we've often had, where we've got two real roots. Okay, so that is two x-intercepts. And we've seen different ways to figure out what they are. The most basic way was by factorizing. Okay, then the next situation is where we've got a parabola and it just touches the x-axis like that. Okay, so for example, that might be at 3. And so the equation of this one could be x minus 3 squared, right? Or it could be 4 times all of that. Right, so that's our equation here. In here, I'll go back to this one and put in some numbers. This one could be negative 4, and this value could be positive 2. And so the equation could be x plus 4 times x minus 2. Or, because I don't know the value of this number here, it could be 3 times that, or 1/3, or something like that. But the important part is that we know that it factorizes and it gives me these two roots here. And in this one, there's one root at x equals 3. The last case is one where it doesn't touch the x-axis at all. Okay, so we call this two real roots. This one is one repeated root. And this one is no real roots. When you get to level 3 calculus, you'll learn that this situation is a little bit more complicated, but no real roots is good for us at level 2. So what we're going to do now is look at 3 specific cases and work out this thing called the discriminant. So here's my first equation. I've got a parabola and I'm trying to solve this. X squared minus 2x minus 15 equals 0. And you can see just from looking that I have enough information to do that here, right? I know that my roots are at negative 3 and 5. So that tells me that y must equal something times x plus 3 times x minus 5. The only thing I don't know is the scale factor. In other words, have I got a parabola that looks like this? Or is it one that goes through those same 2 points, but it's less stretchy, or is it one that looks like that? But in this case, we can see that if we substitute x equals 0, we get out this value here of negative 15. Now we're going to spend some more time on this when we get to our graphing topic, but we might as well do this now. So we've got negative 15 is my scale factor times 0 plus 3 times 0 minus 5. Negative 15 is equal to k times negative 15, so k is just equal to 1. That means that in this case, my equation is x squared minus 2x minus 15. Okay, and you'll see that this parabola has got two real roots. So far I haven't talked about the discriminant at all. But let's think about it. Suppose that we'd forgotten how to factorize, and we had this equation, but we remembered the quadratic formula. So I'm going to solve this one now, not by factorizing, but with the quadratic formula. The quadratic formula is this: x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So here we've got a is equal to 1, b is equal to negative 2, and c is equal to negative 15. So x is equal to negative 2, so 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 15 divided by 2a, which is 2. So x is equal to 2 plus or minus the square root of 4 plus 60 divided by 2, giving us x is equal to 2 plus or minus 8, the square root of 64. Actually, we'll put it in there like that. So 2 plus or minus root 64 divided by 2. So that gives me two answers. I've got 2 plus 8 over 2, or 2 minus 8 over 2, which gives me 5 or negative 3. So when you go back and look at the formula, the reason that we're getting two answers, right, and so these two roots, is because in my quadratic formula, I've got this plus or minus happening. And that's happening because this thing here is not 0, right? And we're getting two sensible real answers because we can find the square root of 64, right? It's just 8. So the square root bit is the square root of b squared minus 4ac. So we've got our first case. When b squared minus 4ac is a positive number, we get two real roots. So if you're asked, just from looking, how many real roots a quadratic will have, this is the only bit of calculation that you need to do. Let's look at the next one, which is one where we've just got one real root. We've got the graph touches at this value here of 3. So we've got x squared minus 6 plus 9 equals 0. Now if you look at that, you can see that you can factorize it into x minus 3 times x minus 3 is equal to 0. That's our perfect square pattern. And that's showing me that there's only one repeated root, and it's where x equals 3. Let's look now at what's going on with the discriminant in here. We've got x squared minus 6x plus 9 equals 0. So what's b squared minus 4ac? Well, a is 1, b is negative 6, and c is 9. b squared minus 4ac will be negative 6 squared minus 4 times 1 times 9, which gives me 36 minus 36, which is 0. So that's why we're generating only one solution. So let's just finish this quadratic formula bit off. But remember, the discriminant is not the whole quadratic formula, it's just the b squared minus 4ac. But in this case, we get x is equal to negative b, so negative negative 6, plus or minus the square root of this, which is 0, divided by 2a, which is 2 times 1. So that gives me 6 over 2, which is 3. So there's our one repeated root. So we've got b squared minus 4ac is equal to 0, giving us one repeated root, or x-intercept. And our last case is one where we don't have any real roots. So we've got a parabola that's just hanging like this, or the upside down version would be one like this. So here's an example of that equation. We've got x squared minus 2x plus 10 equals 0. So a is 1, b is negative 2, and c is 10. So let's do the full quadratic formula on this, and then we're going to look at the discriminant and see why this is going to give us no solutions. So x is equal to negative b plus or minus this. And in this case, we get negative negative 2, so 2 plus or minus negative 2 squared minus 4 times 1 times 10 divided by 2, which gives me 2 plus or minus square root of 4 minus 40 over 2, which is 2, plus or minus the square root of 36, negative 36. Sorry, the recording thing just glitched. Let's see. So there we've got negative 36 over 2. So we've got there's no real, no, this is not real. Okay, we can't find the square root of negative 36 with what we can do in maths so far. So we've got 2, no real solution, or we say no real roots. Right, so here's your quick summary. When b squared minus 4ac is positive, we've got 2 real roots. When b squared minus 4ac is 0, we've got 1 repeated root. And when it's negative, we've got none. Right, here are some for you to try. And I'm just going to put 4 equations in here, and you can have a go at these. And then you can do the walker. Okay, so you can first of all do these, and then you go to your graphics calculator and draw each of them to check. So just go to the draw menu. So number 1, x squared plus x plus 9 is equal to 0. Number 2, 2x squared minus 3x plus 6 is equal to 0. Number 3, 3x squared plus 5x minus 2 is equal to 0. And number 4, what have we got left? X squared minus 8x plus 16 is equal to 0. So I want you to pause the video, try those, and then come back, and I'm going to go through, I'm just going to do the answers for these. Right, but when you're doing your working, you should each time write down A equals, B equals, C equals, and then we need a clear reasoning statement. So for number 1, x squared plus x plus 9 equals 0. This is what we'll say. We've got the discriminant symbol, which is that little triangle. So the discriminant is equal to 1 minus 4 times 1 times 9. Is that right? That's right, yep. Which is negative 35. So we need to say that that's negative. So there are no real roots. Okay, number 2, 2x squared minus 3x plus 6 equals 0. B squared minus 4ac is equal to negative 3 squared minus 4 times 2 times 6, which is equal to 9, take away 48. Again, it's a negative number, so we say that it's less than 0, therefore there are no real roots. Right, so look, these are pretty easy once you get the hang of them. What was the next one? Number 3, not surprisingly. Right, 3x squared plus 5x minus 2 equals 0. B squared minus 4ac is equal to 25 minus 4 times 3 times 2. Nope, that's not right. Minus 4 times 3 times negative 2, which gives us 25 plus 24, or 49. And that's greater than 0, so we've got 2 real roots. That's really, really important that you make that statement when you're doing any kind of discriminant problem. Okay, so back here, we've got to say why there are no real roots. It's because the discriminant is negative. Okay, and the last one we've got left, number 4, we end up getting what? X squared minus x. Oh, so this one here, we have b squared minus 4ac, works out to be 0, so there's 1 repeated root. Okay, so we need to say what the discriminant is and then why we're making our conclusion. If you look at this one, you can see that that's correct because you can rewrite this one as x minus 4 squared is equal to 0. That's our perfect square pattern, and so that equation is going to look like this. Thanks for watching. Go and do the Walker workbook now.